This lesson is on prime factorization. So we just finished talking about how to factor terms, but now we're going to look at prime factorization. And prime factorization means that we're going to split our numbers into prime numbers. A prime number is a number that is only divisible by itself and 1. So prime numbers I couldn't break down any further, like the number 2. 2 cannot be broken down into 1 times 1, it can only be 1 times 2. 3 can only be 1 times 3, etc. So these are all examples of prime numbers because they won't break down further. All of these are considered composite numbers. So a number is either prime or composite, with the exception of 0 and 1, which are neither. Composite numbers can be broken down into 2 parts. So maybe 2, maybe more actually. So 4 is 2 times 2, and also 1 times 4. 6 is 1 times 6, and also 2 times 3. 8 is 1 times 8, and also 2 times 4, and also 2 times 2 times 2. So you see all of these will have more than one way to factor the number. So when I'm looking with prime factorization, essentially I'm going to make a factor tree, and a factor tree is going to help me to break it down until I get to prime numbers. Once I find a prime number, I'm going to circle it. And if I have a composite number, I'm going to continue to break it down until I have all primes. So when I'm working through this, I'm really looking for any value that I think, any 2 numbers that would multiply to 32. And if you struggle with this, then you just get your calculator out and you say, well, I know that it's divisible by 2 because it is even, right? So I'm going to divide it by 2. And if you can use your calculator or, do your long division on the side, 2 goes into 3 1 time, and then 2 goes into 12 6 times, and so 2 and 16. Now 2 is a prime, so I'm going to circle it. 16 is clearly not prime. 16, again, if you know 2 values that multiply into it, do that. Otherwise, I can see that it's divisible by 2 because it's even. I know that it's also divisible by 4 because 16 is 4 times 4. 4s are not primes because they can continue to be broken down. So this 4 I'm going to call 2 times 2. And this 4 I'm going to call 2 times 2. And once everything has been circled, then I know I'm done. So the prime factorization of 32 is 2 times 2 times 2 times 2 times 2. You might also see that written as 2 to the 5th because it's the same factor 5 times. We're going to do a factor tree for both of these. Again, not a bad idea to use your calculator as you move forward. Again, if you get overwhelmed because the number is very large, use those divisibility rules we just talked about. So this is obviously even. I know that 2 is going to go into it. So 2 and what? Again, feel free to use your long division. 2 goes into 13 6 times. And then 2 goes into 16 8 times. And so 2 and 68, 2 gets to be circled because it's prime. And then 68, again, this is even. So it's fine to keep using those 2's. 2 goes into 68, 2 goes into 6 3 times, and into 8 4 times, so 2 and 34. And you can continue doing that. 34 is 2, and then of course you can off to the side do your 2 into 34, so 2 goes into 3 once, and into 14 7 times, so 2 and 17. And then we look at 17, and the more you do this, the more you'll recognize that 17 is prime. If you're not sure, then say, I know that 2 doesn't go into it because it's not even. I know 3 doesn't go into it because 1 plus 7 is 8. If 2 doesn't go into it, then 4 is clearly not going to go into it. 5 does not go into it. 6 does not go into it because the rule for 6 is actually that 2 and 3 both go into it. And so it's very clear pretty quickly that I don't have any values that go into it. So my prime factorization is 2 to the 3rd times 17, or 2 times 2 times 2 times 17. For 243, not even, so I can't use the 2 on this one. But if I look at 2 plus 4 plus 3, that's 9, and 3 goes into 9. So I'm going to use a 3 on this one. And again, feel free to use your long division. 3 goes into 24 8 times. And then 3 goes into 3 1 time, so 3 and 81. 3 is prime, so we circle it. 81, again, 8 plus 1 is 9, so we know 3 goes into it, but most of us can look at 81 and know that's 9 times 9. 9 is 3 times 3, and 9 is 3 times 3. Remember, these are always numbers that multiply. And now I'm done because everything is circled, so my answer is 3 to the 5th, or I could write out 3 5 times. Here are 2 for you to try. So press pause, do the prime factorization of each, then press play to see how you did. For my first 245, I'm going to start using 5 because it ends in a 5, and I know, therefore, that 5 goes into it. And so 245 divided by 5, 5 goes into 24 4 times. 4 times 5 is 20. 4 is left over, bring down the 5. 5 goes into 45 9 times. So 5 and 49. 5 is circled because it is prime. Then I look at 49. You can go through your divisibility rules. Most of us know that 49 is 7 times 7. And now I'm all done. And so my answer is 5 times 7 squared. Notice that I'm writing the 5 before the 7 squared because we write things in numerical order. For 10,000, obviously this one is fairly simple because it ends in a 0. And so I know that 10 goes into it. And of course, I shouldn't have to write out my long division here, but 10 goes into 10 once. And then of course these will be zeros. So this is 10 times 100. Now 10 is not prime. So even though I just broke it down into 10, 10 is not a prime number because 10 breaks down into 2 times 5. 100 continues to break down. So I could call that 10 times 10. And each 10 is 2 times 5. Remember, you have to keep going until everything ends up with a circle at the end of it. So now I have 1, 2, 3 2s, so 2 to the third, and 1, 2, 3 5, so 5 to the third. That is my prime factorization.